All right, I finished the high-speed Huff and Puff stabilizer unit, and you can see the last digits bobbling around. It's staying pretty close. I haven't made any adjustments. I just turned it on for the first time. Uh, I have run this oscillator here. Just let me turn this. I want to show you some other things. I have run this oscillator, and it slowly creeps down in frequency. But with the Huff and Puff high speed, not even adjusted, not even sure I got the right range or anything. It's staying in one little area. Okay, so basically the project's finished. It just needs some fine tuning. I wanted to take a couple quick things. In this case, I used the Franklin oscillator, which is back here. This is the high-speed Huff and Puff board. Okay, it's got two transistors on the input that raise the signal level of the Franklin oscillator into a square wave, so it can go into the 74HC 4060, which is a divider chip. Let's call it a divider chip. Here you have a crystal oscillator, which is 60 megahertz. I believe it should be a 50. I'm using two different circuits, so I have to make some decisions whether I want to order a 50 megahertz, so it'll be more compatible with this circuit. But what I wanted to tell you is on the schematic, you'll see an LED light. Okay? I hate this thing, it works backwards. Here's an LED. It shows light coming out of it. This LED does not light up on this unit. It's used as a varactor diode. So the signal comes in from the Franklin oscillator, which is a very stable oscillator. It goes through a circuitry like like a little frequency counter. It within a certain range, it produces an error signal, which then goes over to the varactor LED, and then makes a certain amount of capacitance, which brings the oscillator back on frequency. That's how it you can read up on it, and in your mind you can memorize how it actually works. But in other words, I did finish it. It is working compared to it being switched off. If I disconnect this wire here, the oscillator will slowly drift down in frequency. All right, and I have up here. Let's see if they get the pointer here. Okay, this is a digital frequency counter from eBay. Now you don't know if that's bobbling. You don't know how much that bobbles between digits, but you definitely see a difference when you put the Huff and Puff on. And this Huff and Puff still hasn't been zeroed in yet. There's an adjustment here. I haven't played with that. I have to do more reading, but I just wanted to show you I did finish it, and now it's at the point where I can clean up the mess, and then I can sit and see, do I want to improve this? Okay, there's a couple other questions I want to ask, and then and confirm, and then finish this up, and then this will go in a box somewhere. But after going into this, it's a very steep curve to get into this project. Okay, if you go back and look at my other versions, I built the first unit, which was really for 5 megahertz. It's for another country. This circuit was developed in another country. It wasn't really made for the United States. And then that one I told you was the best, the Holy Grail. That guy there, he went and made it work for 120 meters, 80 meters, 40 meters, all the way up. And he stayed with it. He did the work. And that's who helped me out the most, seeing what he went through. And he was answering the questions I was asking somebody else. And the deeper you go into any subject, the more questions you're going to have. But I do the work just so I'll understand. And this building all this isn't practical for a receiver, for a radio that has very little left on the frequencies. There's very few hams on. There's very few shortwave stations. But I had seen this thing, and I got curious. And I said, well, let me go in that direction. Okay? And that's how I am. All right, I just want to show you. Now, the last video I did on this, showing it before I finished it, there's a lot of people clicking on it. I think they're just clicking on it because of the title. I don't think they really understand, you know, this is what they did just before phase lock loops and the DDSs got popular. Okay? And I kept thinking somewhere along the line, somebody had come up with a simple oscillator that you could just turn the knob and it stays really accurate. And I did that with a Franklin oscillator. But I wanted something like almost perfect, like better than crystal control. And you could say, yeah, DDS units, but they put out so much noise. I noticed that a really good shortwave radio years ago, if you disconnected the antenna from it, it didn't make any noise. And then when you put the antenna on, you get background hiss from the atmosphere and stations. Where a lot of these modern radios, even the R71A, there's places where you're picking up the display. On the R71A, the display capacitors go bad after a while, and they start making noises on the band. The phase lock loop circuit has some birds on the band. You know, they're frequencies that you think someone's putting a carrier out, but it's actually the radio. And a lot of the old tube sets, you went down, up and down the dial, and the only thing you picked up were stations. Okay, you didn't pick up the radio itself. And a lot of these solid state things, it started like actually with the scanners. You'd buy a scanner, and in the instructions they'd have frequencies that you couldn't pick up with the radio because the radio was using that frequency for its microprocessor and stuff. And we used to call them birds. And it just, I don't know, it just seemed like the quality went. But see, they're looking at what does the person use the radio for, and what is the price point, and that's how they design it. And you come along having seen real good quality, and you look at the radio and you're like, this is a piece of junk. It's like that software-defined radio I bought. I don't have it handy to show you, but it's a piece of crap. I mean, an absolute piece of crap. And they're selling millions and millions and millions of these things. It gets almost every frequency on Earth, but not even well. But that's not what people are all about. Bragging rights, ego, I have this, I bought that, I'm going to improve this. That's what it's become. Okay, and a lot of things have gone that way. But I just want to show you, I did finish this. And this chassis was a kitchen regenerative. Okay, and I've repurposed it. And I kept all the leads short. Every board is grounded to the chassis through a little jumper, and it also has a ground wire between them. And you got to make sure you don't make a ground loops. But that's something you might want to read on. But it's finished, and I can clean up, and then I go back into this and see how accurate I can make this thing work. I might need to buy that other crystal. I think that's it. All right, that's it.